Thank you.
Yeah, so MAQ is quite a new company on the market, and we are founded in 2016. Sold our first two in 2018 or close to 2019, and then all of a sudden COVID hit us so badly, and but still we were able to grow the business in the meantime. So my name is Shelin, and I got my PhD in the Technical University in Cambridge, one of the top technical university in Europe. You can find my email and also my phone number in case you want to reach me. And the tagline or the vision from our company as MAQ is to simplify machining, and we do that by reducing the vibrations in the metal cutting processes. In the presentation today, there's a generic technical overview, and we're also going to share some of the market feedback, some common issues, and I think the last part of the opportunities and closing the deal and so on, those you already have a very wealthy knowledge for how to reach the clients and so on. So I will not go too deep to that, but it's I will also mention a little bit about the expanded portfolio. At MAQ, we believe we have found a novel way to address the vibrations in milling, turning, and also hole making process. The products we have made is purely plug and play. There's no need for adjustment, so there's no adjustment mechanism. Plus, it's purely dry inside. We don't have any oil inside the bar. And one of the unique advantages is that we have one tool that can compete or replace several from a competition brand. And here I would like to spend a few minutes to explain what actually creates the vibrations in the machining. On the right hand side, I have made a small animation where it simulates the cutting edge. The yellow part gets engaged with the workpiece, and with the time going by, what happens is that a small excitation on the cutting edge will leave a mark on the surface, and the marks or the waves on the surface starts to have a frequency that is exactly the same as the resonance frequency of the cutting tool structure, so that tries to excite the tool much more. So you have a feedback loop in the system. So if when you excite the tool leaves a mark, and this mark excites the tool even bigger in terms of the vibration amplitude. So this is what we talk about in machining. In other words, the vibration phenomenon in machining, it is generally, or it exists everywhere. So the only difference is that sometimes you hear the difference. You hear the sound. You look at the surface finish, and then you realize that you have vibrations. But otherwise, in most of the cases, you have a vibration in the process, but it doesn't really bring much of a problem for your process, so you just keep it as it is and you accept where you are. So in my world, there's definitely not any machining process that is vibration free. So all tools vibrate. That's the difference if you ask me as a technical person. And there are several theories trying to explain the phenomenon behind what creates the vibrations in machining, but the most widely acceptable model is the feedback loop between the cutting process and the cutting tool structure. I have someone else coming into the meeting. I need to get in. Yes, now you helped me just now. All right. And to reduce the vibration, the most nominal way or the most cost-effective way is to make a mass damper on the cutting tool structure. So you suspend a heavy mass on the cutting tool structure. So this is exactly the same as what you have explained just now. I mean, to have a mass supported by some polymers or materials trying to build a mass damper. And MAQ has the same concept, that is to use the mass damper to reduce the vibrations in machining. And what the major difference is that we have used a very special polymer to support the mass, and these polymers they change their properties with the vibrations over a much wider frequency range. Typically, vibrations are taken as a detrimental effect in machining, and the mass damper is the most effective solution so far as we have seen on the market, or even in the academic area. And here I try to explain what is a mass damper. So I have a moving object on the left hand side. You can see that when you have a force excited on the moving object, you try to make this moving object to move together with the force. And what this mass damper does is that it tries to make a short circuit for the energy flow from the force towards the mass damper, so that you more or less make a short circuit effect for the energy flow, so that the moving object does not get any energy from the vibrations. So you try to isolate the moving object from the disturbance or the force, and that is what we do with the mass damper. So to transfer the energy of the vibration towards the mass damper and stabilize the moving object. In this case, the moving object is the cutting tool structure. To make the mass damper working effectively, is quite important to match the frequency of the mass damper to the frequency of the moving object, and this is what we call as the tuning. And this is a natural phenomenon. I mean, if you look into back into the old days, where when you listen on the radio, you have to tune the radio to the correct frequency. Otherwise, you will only hear noise. So if you tune the radio to the correct frequency, you will receive the energy from the radio station, and you will be able to hear the music and people talking. So that's basically the same phenomenon. It's just nature. I mean, if you want to have the two systems to talk to each other effectively, you have to have the same frequency. And the frequency of the mass damper is decided by the suspension stiffness, the K factor, the stiffness of the spring, and the weight of the mass damper. And in the system, it's quite important to change the stiffness of the system instantly as multiple frequencies occur, and this is exactly what MAQ is trying to do. So if we look back to the history, the mass damper is not new on the cutting tool structure. The first generation came in the 1930s, and back then it was an inventor who was very well known in the electronic area. And what he did is that he used a heavy mass suspended by fiber disc, compressed with some friction force. And this was exactly the same time when clutches becomes to be widely accessible in the automotive industry, or on the vehicles. And in the 1960s, the rubber becomes to be readily available commercial material. So then people started to use the rubber rings to replace the fiber disc and make the compression of the rubber rings to change the tuning of the mass damper. So if you use the fiber disc, the problem is that after a while it gets clogged, so it's not possible to retract and retune it. It's very often they get more or less like welded effects. It's quite difficult to use, but then the rubber has the advantage that you can fine tune it, and you can really release it and retune it again. So that's the advantage for the rubber rings. And then in the 70s we started to move the tuning screw from inside the tool body to external outside the tool body, so you can set up the tool in the machine and then fine tune it. So you will save some unnecessary steps from dismounting the tools when you do the tuning step. And that was also the same time when people start to mention that we actually can put some viscose oil inside the mass damper. So the second generation, you can say, is very similar to what Seco is today using. I don't know if they have changed the design, but back in the days they have used the rubber rings to support the mass, and they have used different different rubber rings to in the same construction. And in the third generation, this is very similar to the Kenemato solution today on the market. And the fourth generation is very similar to Sandvik Silent Tools, and also eScar, this whisper line from eScar, where they have the rubber rings, but then they put some viscose oil inside to enhance the dampening effect. But if you look back to the history, I mean, the starting point of the mass damper solution is to make the tuning. I mean, the damping comes afterwards, but to make the mass damper working effectively, the tuning is the most critical part. Was there a question here, or?
Oh, I agree. I know the third generation is the one I recognize from Kennametal days. Very similar.
Yeah. When I look at the problem back in the days, I mean, it is also to have the mass damper working effectively, it is necessary to make the correct tuning. And if I look at a bar, for example, in a machine, and in this case, I look at the 20mm bar, that is 3/4 of an inch equivalent. And I put this bar at different abatement ratios from 6 times the diameter up to 10 times the diameter. You can see that with the change of the abatement ratio, the measured vibration frequency, the most prominent vibration mode, the frequency gradually decreases when you extend the bar with longer overhand. So we all know that if you increase the stick of the boring bar, you also decrease the vibration frequency. And the real situation in a shop floor is actually much more complex comparing to the illustration here, because all the effects, all the factors come together to affect the vibration frequency on the cutting tool structure. So the wear on the joints, the bed of the structure, the temperature, the humidity, and so on, they all have an impact. Even the operator has an effect on which frequency the bar is mostly likely to vibrate, depending on how hard he clamped the bar. So this is actually the challenge in the industry today, as we see that is often not able to predict which frequency the bar is going to vibrate. I mean, it can predict a relatively wide range of frequencies, but it can never predict so precisely, so to say.
The question, obviously, speed feed depth of cut has a huge effect on that as well. So if you know, with the third generation, if you change speed feed's depth of cut, you got to retune the bar. So does your bar take that into effect as well as a variable?
We do take that as well. I mean, what we look at it only is the frequency. Also, if you have a different depth of cut or feed rate and you excite different modes, you have a different frequency. So what we purely look at is the frequency. It doesn't matter what creates the change in the frequency.
Okay, thank you.
So, and this is what we call as the 5th generation. And this is a simple construction for turning tool structure. On the right hand side, you see the insert, the cutter head, and you have the bar. In the middle, we have a mass damper installed. The red part is the mass, usually made of tungsten alloy, and the green parts are the polymers, which we use as a specific material that has frequency-dependent stiffness. So this material is quite special, I would say. When the frequency increases, the stiffness of this polymer, they increase. So when the frequency of the cutting tool decreases, this polymer, they just get softer. All of a sudden, you have an automatic tuning function, because the polymers will react to the different frequencies to make an automatic tuning for the mass damper. And there has been quite many questions from the readers. How is this possible?
Yeah, that would be mine.
And actually, if you look into the literature, I mean, if you study the non-Newtonic materials, you will realize that rubber has a similar property, but rubber has the change of the stiffness is relatively 10 to 15% if you increase, let's say, from 100 to 1000 Hertz. So that's the behavior for the rubber. Therefore, it's not possible to use rubber to have the same phenomenon, because we have talked a lot about the deciding factor here, the K factor, because if you increase the frequency by double, the stiffness of the support has to increase 4 times to make a match. So if you increase the frequency by 10 times, then the stiffness has to increase 100 times to make a match. So that is the critical part. And the rubber can only change 10 to 15%. Also, even though it has a frequency dependent stiffness as well, but it's not suitable to make automatic tuning function. And that's the limitation for the rubber material. And we are different. So we have used the polymers, which changes the stiffness drastically, so to make automatic tuning function. And this is not the same material as rubber. It's actually a different family of material. It has a nanostructure inside. So the structure size in the material is roughly 20 nanometers, and that is quite critical for the performance of the material when it comes to the automatic tuning function. And this is purely new in the academic research, because it's I really had a hard time to explain it actually back in the days, but now I think most of the research fellows, they understand what I was trying to do back in my study. So when it comes to the comparison, in this case I have compared a 25 millimeter product, so it's equivalent to 1 inch by 10 inch in the length, so 1 inch in the diameter and 10 inch in the length. The red is the competition product from the market, is from the leading competitor, the biggest in the world in this area. I guess everybody knows who that is. And we put the bar at 6, 7, 8, and 9 times the diameter, and the green represents the MAQ product. So the competition product on the market says that this product is designed for up to 7 times the diameter. After that, it starts to have a very limited performance, or you can say that very often you can't really use it. And if you compare the vibration amplitude, so the x-axis is the vibration frequency, and the y-axis is the displacement. And we look at the green and red comparison, where green represents MAQ, and in that case we actually reached a reduction of the vibration amplitude between 25 up to 45% depending on the setup. So this actually means if you use those two products in your machining, you will be able to boost your productivity by 25 to 45% depending on the setup in your machine. So that's the advantage when you talk about the MAQ products. Also,
when you say productivity, what are you basing that on? Tool life?
It's no, we normally base the productivity based on the cutting speed and also feed rate. The selection of the cutting speed and feed rate. Tool life is also another factor, but it is not directly related to the productivity.
So you're saying you can run it basically, you can run it faster, you can do more metal removal with this?
Yeah, exactly. And you don't have to slow down to make it stabilize. And that was actually very often, if you look at the end user, they try to make it slow. But we don't. I mean, you can just run as regular speed and put it on and see what happens. You don't have to be so careful, you can say, when you use our products. It's more like a general machine. It's just like another typical machine you run in your workshop. It's going to work as it is.
Yeah. I mean, the first thing you do, you hear chatter, you start to wind the feedback. Wind the speed back, sorry. Yeah. So, I mean, if I look at the how to say, the innovation cycle in 100 years, there were like 20 years in
as a cycle, you know, 20 years afterwards, there's a new thing coming out. So to reach another 25 to 45% comparing to the, you know, the best next alternative on the market, this is massive if you talk into the machining, because we are chasing after 5 to 10% difference. Yeah, and it's also more interesting to look at the machining result. In this case, we machined in the 4340 pre-hardened steel. So it's a pre-hardened steel with a Rockwell hardness between 28 to 30, and we have used a 0.4 nose radius insert at 0.5 millimeter in the depth of cut, and we compare the 20 millimeter product, or 3/4 of an inch product, comparing to the leading competitor's product. We settled to at different aperture ratios and test the different speed and feed. What you can see from the measurement, you can say is generally that the speed has very little impact on the vibration behavior for the two products, but in case of MAQ, you can really push the speed to the limit and run the feed at the limit, so that you can cut more materials in a given time. And what's most interesting here is that we have roughly 90% success rate when you do this kind of blind test. If you look at the result table, and the competition product has roughly 40%. So we have a doubled success rate compared to the leading competition on the market. So that's a direct benefit, because it has a much higher success rate when you make the first try. On the other hand, I should also highlight that I mean it's like for me any two web brace. I mean, it's just like if it comes to the level where you categorize this phenomena as a problem in your machining. So we still have vibrations in our tools, but it's much less compared to the competition product. And it's also more interesting to look at the surface finish. So if you look at the surface finish from the experiment that I was just trying to show, you can see that when you put a 6 times the diameter, you have pretty much not much of a difference compared to the competition product. But once you increase the aperture ratio, what happens is that MAQ constantly produce a better surface compared to the competition. So this is also a phenomenon which we also often hear from our end users. You know, they normally say that they don't hear much of a difference when they use the two products in their machining. But once the part came out from the machine, then they look at the surface, and it's really much smoother if they have used the MAQ product.
What's the max L to D you've gone to?
Today is up to 15. Today is up to 15 times the diameter if you ask specifically.
Thank you.
We have also made a... Sorry, go ahead.
So we're pushing 16 times speed, right?
Yeah, exactly. We have also tried to exceed the 15 times, up to 16 times the diameter, but then the so we normally rely on this kind of performance table where you can really see the selection for the feed and speed. So you can also increase up to 16 times the diameter, but then the selection for the feed and speed is a little bit, you know, limited. But you can still successfully do machining. That's not a problem.
If this is as good as you say it is, it's pretty impressive. Pretty impressive.
That I think you have to find out.
Yeah, I'm old-fashioned. I want to run one. I want to stand by the machine and run it and see what goes on. There are products out there today that talk about the sweet spot and measuring the vibration of, you know, actually putting an accelerometer on the tool and tapping it and measuring the inherent vibration, and then it calculates the sweet spot, as they call it, of speed, feed, and depth of cut to eliminate vibration. But it's a long-winded setup and takes forever, and it's not, I don't know, it's probably 50 to 60% successful.
Yeah, it is, and we know exactly the reason behind. We are a new company, as you can see. I mean, we started basically everything from our website, and I normally recommend all our partners or fellows to browse over the website to get some more insights, to look at the blogs, particularly to look at the blogs where we have the new product release and so on, where you can really gain insights to what we do here at MAQ.
Do you sell the inserts, the carbide as well, or I notice it's ANSI-ISO standard, so people can put that in there.
We have a private label insert supplier from within Europe. We have a private label insert supplier, and the reason is we need to know how does the product perform with different chip breakers for different materials. So we do have a list of inserts, but that's more because we wanna guarantee the performance for our products. So. And we normally, when we ship out the product, we normally put the insert as a recommended for them to start, so they know that it's necessary to follow the guidelines. Not
as long as it's ISO standard, we know it's not proprietary. That's the main thing.
It is ISO standard, yes.
Yeah.
Yeah. The direct benefits when you use MAQ products is that it really stabilizes the machine at higher cutting speed. You can reduce the number of the post operations due to the better surface, and you can reduce the tooling cost because the cutting insert has extended the tool life. And not even to say that you can also reduce the scrap rate, and we can reduce the number of tools you need from covering from 3 to 15 times the diameter. And as an indirect benefit from the end user, normally they comment that they got better straightness of the machined bore on machined part, and they also have a less of a dimensional variation when they look at the machined part. And as one of the effect, it is actually we managed to increase the tool life as well, measured by the flat wear. But you know, the tool wear has different measures. We normally look at the flank wear for the inserts to decide if this insert now is end of the tool life or not. I should also highlight that the MAQ product by itself, I mean, it's the tool itself has a great value for the customer. And in this case, I mentioned the 32 millimeter with a length of 416 in millimeter in the length. So it's a one and a quarter inch in the diameter equivalent. And this product is designed on the market today. Is designed for up to 10 times the machining. And if you have a customer who needs to do machining at 11 or even 12 times the diameter, if they go to the competition products, they will say that, well, exceeding 10 times D, you need a carbide reinforced bar from the back. And the starting price is roughly $10,000 for that product to start with. And MAQ really makes it possible with a steel body. The same tool, you can see that it works 9, 10, 11 without any problem. At 12, you have to use the correct parameters, and then it really has a good performance there as well. So, and it can save roughly $8,500 from the start of the project. It is really that the tool is more flexible compared to the previous technology. It really has a better performance. It's worth trying, and it's with that said, I mean, we are not trying to shove down the price on the market to compete, or is the price only. It is really the technology inside allows us to do it even better. All our distributor has the access to the Dropbox folder where you can find loads of commercial materials like the videos, the presentations and so on, even the press list and so on, where you can take as the resource if you're going to visit your customers and so on. If you don't have the access to Dropbox, you should drop an email to Christian to fix that for you.
Yeah, I got it. He sent me that, so I've got all that information.
Great. So simplified machining is the vision for MAQ. So we only focus on the concept, or our vision, that is to simplify machining, where if you do the traditional alternative, when it comes to have a vibration issue in the machine, normally what you do is that you slow down the machining. You probably have to consider even change the tooling or the machine. Sometimes you even think of to change the part, which is not usually an option for the customer of the workshops. Or you can also buy a DevApp tool from a major vendor on the market that has a limited performance and lots of restrictions. MAQ instead, it's a really plug and play. There's no need for extra capital software or new hardware. It's maintenance free. There's no wear components inside. There's no leakage of viscous oil, which is a typical known problem on the market. We don't have that. And it's really the self-tuning function that it makes it no need for adjustment ever. So it's really unique, I would say, on the market.
Back in the day, we used to wrap rubber bands around the bars and everything to try and stop that vibration.
Yeah, sometimes works, right?
Sometimes works. Most of the time it doesn't.
You know, it's a big challenge in the academy to try to explain what has happened there. We tried hard, we couldn't explain, you know. Sometimes works, sometimes doesn't.
Yeah.
But in this case, it always works. So that's the difference. MAQ product normally has a higher success rate when you make the first try by the end user because of the wider operation window. And we also have seen that the leading competition product have their product very well optimized for certain range. And if the competition test performs in those certain ranges, MAQ product may have a hard time to win the case because the two products may perform on the equal to the same level in some extreme cases. But as soon as the presetting is changed, or we moved out from the comfort zone from the competition product, such as the aspect ratio is changed, or even change the machine or the operator, then MAQ product will show its unique performance and try to show its strength over the competition, that it has an automatically tuning function inside to adapt itself to the new situation. We also know that the clamping of the boring bar is as important as the dampening solution itself in the setup. We have summarized a few types of clamping on the market. The direct screw mount means that you clamp the bar directly with screws, and it's not really acceptable because of the bending stiffness and also the low bending stiffness, and also you have the possibility to damage the damper package inside the tool. So we normally say no to the direct screw mount unless you have a clear understanding what you're doing in the machine. And we normally suggest to start with the reduction sleeve, which has fairly good acceptable bending stiffness. And that's a starting point usually when you want to use the vibration damp the products. Or you can also think of the all-around clamp system. Sometimes some of the workshop has the possibility to use the all-around clamp systems, and it has a little bit better bending stiffness. And for the applications where the add-body ratio exceed 10 times the diameter, we really recommend you to contact MAQ for suggestion how to clamp the bar correctly. And we normally suggest the Hydrofix fixtures, which has a fairly good clamping stiffness and doesn't really require a long clamping length either. So the clamping is quite important in many cases. And when you use the tools, you should use a short fixture, because the shorter the fixture, the higher is the rigidity of the fixture in terms of stiffness. And some of the customers actually try to use the bar with on a very long fixture, and then of course it doesn't work because the vibration by itself is a rather complex phenomenon, and if you have a long fixture, the problem comes from the fixture, not from the tool anymore. So that is difficult to handle. And if you have the possibility, running in a CNC machine, the external tool mount is more preferred compared to the internal tool mount, such as the VDIs. The external tool mount has a higher rigidity, is more recommended, and the internal tool mount usually has a lower rigidity in terms of the stiffness. And if you use a reduction sleeve, you only need to clamp with the screws on one side. Several of our end users actually, when they receive the sleeve, then they start to clamp from all directions that they have a screw that which they can apply, and that's actually wrong, because if you clamp on all the surfaces, you have a high pressure, but you also have a low contact surface. So in order to build a stiffness in the clamping, you need both the contact pressure and you also need the contact surface. Those two factors goes hand in hand if you want to increase the stiffness in the clamping. And we have also seen that some of the big brands on the market, they have this a typical like the left hand side where you have the VDI on the back and you have a fixture, and they say this is a split sleeve clamping, and then they say this is recommended for vibration damped machining tools, which is totally wrong. Because if you look at the design, they have made a slot in the middle of the fixture, which you have reduced the cross section of the fixture by half in this particular area. And we talk about bending stiffness. So in that case, this fixture, if you have a slot in the middle, is not good at all for any tools. And unfortunately, there are some big brands on the market promoting this kind of fixtures and say this is good for the end user, and we totally forbidden it to our end users. We could also have when we talk about the split sleeve, we talk more about the correct setup to the right hand side, where you really have a rigidity in the clamping without sacrificing any cross section in your setup. So the bending stiffness is maintained to the maximum. The rule of thumb when you do machining, it is that use the depth of cut above the cutting edge radius, and most of the time for the carbide is roughly 50 micrometer for the carbide. So it's when you do machining with the damped bars, you should maintain the depth of cut above say 70 micrometer, and you have to use a feed rate that is also higher than the cutting edge radius. That is again roughly 70 micrometer for the carbide inserts. The reason is if you have a too low depth of cut or too low feed rate, what happens is that the cutting edge is gonna plough or rub on the surface and without cutting, and that actually excites more vibrations compared to if you do the actual cutting operation. And you should use a feed rate that is larger than a quarter of the nose radius. So if you use a 0.4 millimeter nose radius, you should start with the feed rate about 0.1 millimeter per revolution. So that's the rule of thumb in most of the applications. To align the bar, we have two solutions. The first is that you can use the central line on the bar, which is aligned to the cutting edge position. And in those cases, you use a plunger ball, which can sense the location of the bar, and then you clamp the reduction sleeve, which has the plunger ball on the installed. On the other hand, all the cutter head from MAQ today, they supply a fairly big flat surface for you to make alignment. So this is much easier to align. And we use this digital speed level together with a magnet. So you have a small surface on the bar. In this case, the bar in the picture is a 10 millimeter bar, which is 3/8 in the inch. So it's quite small. But then we still see that it's quite easy if you use the digital speed level to make alignment of the bar, because it's you can find a reference of the zero, and then you can use the magnet to position the digital spirit level and find the zero there as well. So then the systems are very well aligned. Our serial lock interface on the bar is exchangeable to Sandvik and also to ISCAR, and that means it's quite many of the end users, they have a Sandvik bar or they have a ISCAR bar, and they have the cutter head as well. And what they do is that they get MAQ bar and they took the screw from the old system and try to clamp the same cutter head on the MAQ product. This is not okay, because the hole that is used for clamping the cutter head is a blind hole. So if the screw that they have to use is longer than what it should be, then it's not possible to clamp the cutter head in a correct way. And in the middle of the machining, what happened is that the cutting force will actually move the cutter head away from its correct position, and it starts to create problems. And also I need to mention that we don't use the same screw system. So Sandvik, for example, they have a few of their serial lock interface using the inch screws, and we have the matrix system. So if you use the MAQ product, you have to use the MAQ screws to clamp the cutter head.
Just to be clear on that, if you could go back 1 second. So the ISCAR and the Sandvik heads will fit if you change the hardware, if you change the screws.
Yeah, but you have to use the screw from the bar that we provide.
Perfect, thank you.
Yeah. And to reduce the vibrations, this is very well accepted guide now when you do machining, is that a positive insert has less of vibration, and a new and sharp edge has less of vibration in most of the cases. And the smaller nose radius also has less vibrations. But in this case, we normally recommend the customer to start with a nose radius of 0.4 for several reasons. Because if you have a too small nose radius, the feed rate is also low, and usually the workpiece is quite long. So sometimes the insert gets worn out before you can even finish the cut. So we normally recommend to start with a nose radius of 0.4 as the starting dimension, and place the lead angle close to 90 degrees also reduces the cutting force in the radial direction, and that also helps to reduce the vibrations in general. We have also been asked a few times what is the runout that you can achieve with the MAQ bars, and we normally say that for the tolerance up to 10 times the diameter, for tolerance of H7 is not a problem. If you have above 10 times D and you want to reach a 7 grade tolerance, H7 for example, tolerance, you have to make sure that you have everything set up correctly, because the everything affected the accuracy of the machine part. But it's doable. It is possible to do. You just need to have the correct setup. And when we talk about runout, here I have tested a 25mm bar, and it's or it's equivalent to 1 inch, and we set the bar at 9, 10, and 11 times the diameter, working in the pre-hardened steel of 4340. And in that case, we can see that for the most of the cases, we have actually reached the runout less than 5 micrometer in the machine workpiece. Also, you have to make sure that it's correctly set up. Otherwise, it's but it's to reach a runout less than 5 microns is not a problem for MAQ. And in this case, I also look at the video where I demonstrate the movement of the needle in the workpiece surface. You can really see that when I say that it's less than 5 microns as the runout, it's actually less than 2 microns. But of course, the depth of cut, the feed rate, and everything come together affected the runout that you can achieve in machining. So we started from our website. It's a great place where you can get a conversation started. You have a technology explanation video, which we explain the K factor and the difference and so on, where you can also find the product page that is easy for you to browse over, and look at the data sheets, for example. And we also have a white paper for engineers who wants to learn more about our technology. We try to update every year, but this time we're gonna do it probably somewhere in the summertime. And the product range, we have meter system comparing to metric and inch. And the minimum tool diameter is 10 millimeter and the maximum is 60 so far as a standard portfolio. So 10 millimeter equivalents to 3/8 in the inch system, and 60 is 2.5 inch. And we have apart from 10 and 12, the rest of the products from 16 all the way up to 60, we have a system that can cover up to 15 times D setup as a standard item. So how big can we go? This is the tool we delivered last year in summertime in Italy, where we built a turning tool holder with a diameter of 350 millimeter and the length of 5.4 meters in the length, and delivered to the customer who machined the Inconel steel for oil and gas industry. So the customer has a demand to reach a very high depth of cut, because the what they do in their workshop when they get the forged apart is to clean the surface so they can deliver to the next stage. And in that case, we managed to deliver the product in summertime. It was actually at the same time when we had the COVID problem, but we managed to do it anyhow. And you can see that once the customer put in the MAQ bar, they can really see the difference in the surface finish. And again, I mean, they said it satisfied the need for the depth of cut as well, and they were really satisfied with the result. The bar was like 5.5 tons, I remember, so it was quite difficult to beat it up. It took me a week to assemble everything together, more than a week actually. And I think I will just skip those slides because it's very much for the sales and so on, where I think you guys have most of the knowledge already. For the multitask machines, we have a package solution where you have a adapter in the end, which is made by hydraulic clampers, and you can, in the front, you can select different types of bars and different length. And I think it was from March this year, we also started to have our own backend that can use the reduction sleeve with the PSC50 and PSC63 and also HSK T63 as the standard item for the multitask machine end users. Expanded portfolio. It is the 15 times the product that we are trying to release. We have released this year, and actually now the 40, 50, and also 60 15 times D is ready to ship if there's any order, but we have not published the marketing material yet, but they are done, finished now as the standard item in the portfolio. And we have also the reduction sleeve coming from the inch system as well. And this is so the issue with the reduction sleeve is like this. I mean, this is a standard item from the end users. You know, if you have a bar, you need a sleeve to clamp it somehow. And it has been like that, where the customer buy a bar from MAQ and then they have to go to somewhere else to buy a sleeve. And if they buy the correct sleeve, they cost a fortune. So that's why we decided to have our own sleeves, because we want them to use our own system, so they don't have to bother too much to go around and ask for different quotes. You have the
Just
reduction sleeve. Sorry.
Quick question,
Sure.
if I might, because I have to jump in a couple of minutes. I've got a 10 o'clock call. What about coolant? Is there any through coolant capability on this, or is it flood?
Yes.
What is?
through coolants. Can you get coolant through the bar?
Yeah, it is. It is through coolant. Yes.
Thank you.
It's only in the 10mm and a 3/8 that does not have a coolant in the middle, but the rest of the product, all of them have a coolant in the middle. Yes.
Okay. I do have to jump. I have my other call waiting for me right now, but I really appreciate this. I want to see this thing work. That's my next step. I want to go run one.
Yeah. Yeah.
Right. Thank you, everyone. I apologize. I got to jump right now.
No worries.
Mark, let me know if you need anything.
Thanks.
So one thing I wanna also mention is that when you select the cutter head, for example, if you look at the bar, 40mm bar or 1.5 inch, you have two versions. The first one is the 1C in the middle, where you have one coolant channel in the middle, and the other one is a 3C version, which you have 3 channels of coolant, one in the middle, 2 on the periphery. And if you select the 50 or 60 bars, then it's only 1C in the middle as the standard option. And when you select the cutter head, it's quite important to remember there are 2 different types. The first type is the P version, which we call the P version. It has a peripheral fluid only. And the other version is the CP version, where it has a central and a peripheral fluid. And if you have the CP version, then it doesn't matter which interface you have on the bar. It is going to work as on both versions. But if you have a P version cutter head with only the peripheral fluid, you cannot select the 1C bar interface, because then the fluid cannot get to the cutting edge. And this year we started to make it easier for the end user to select the bars, and where we updated the workable length in the catalog, where you can really see the length range where the products are functioning well, you can say. But if you are outside the range a little bit, it's not a big problem, but that's what we recommend. If you have those length, it's better to select the correct bar to start with. And we have this 3xD series, which is a short product. Normally we say that if it's above 7xD, you start to use a damped bar, but below that you normally tend to use a carbide bar. For MAQs, the story is different. We have developed these 3 to 6xD application products, or we call it 5xD product, the short one. And we managed to beat the carbide in both performance and also cost. This is a really good product because it really allows you to use the wiper edge insert in internal turning process. If you read the commercials from the wiper edge, everybody says that it's a great product. It increased the cutting speed so much and the feed rate so much that you can save a lot of machining hours. But the only limitation is that it should only be used when there's no vibrations. And in this case, we actually use the wiper edge to do machining in the internal turning. You can really see that the 5xD product is really a good choice if you have a challenge in the productivity in your workshop. In the end of the video, I'm gonna share you a 25mm bar at 16xD setup. So it's equivalent to 1 inch, and we put that 16 times the diameter as setup. Yeah, as I commented earlier, if you our standard range covers up to 15 times the diameter, but if you have a challenge at 16 times D, it's gonna work as it is, but you know, you have to be careful with the selection of the machining parameters to make it work. Yeah, that's my presentation for today.
Well, thank
Questions?
you. Thank you.
I'm gonna stop
Questions out there?
recording now. Yeah.